Okay, I got few questions from you. I don't see anybody ask me question from section 3.4, but from 3.5 I saw a few questions, so I'm gonna try taking them up and see if you understand. The first question is and from section 3.5, page 63, number 5b. When you read the statement, question has a function given which is a quadratic function of degree 4. It's asking how many points of inflection this function will have. If a question is just not asking what are those points of inflection, if there are actually points of inflection existing, then we have to actually solve it the way I did. But if this question is kind of multiple choice question saying a function is given, it's only asking how many maximum points of inflection a function will have. So remember, to find points of inflection, we have to find the second derivative, and we solve for second derivative. This is a quadratic function. If I find second derivative, that will be quadratic function. Now, if question says how many maximum this quadratic function will have points of inflection, then my answer is 2. Will it have 2? It may have only 1. It may have only 0. Remember, it depends on the solution of this quadratic function that we get. You know what, quadratic function may have no solution. That means may have no points of inflection. It may have one solution. That means that there's only one point of inflection. If there are 2 solutions, then there will be 2 points of inflection. If a question is asking to actually verify it has 1, 2 or none, and then we have to go and solve it. So this question, I still didn't try to find the points of inflection. I'm just going over if there will be points of inflection or not. So I did find second derivative. If you look here, to find second derivative, we need to know first derivative and second derivative. So I got this f double prime x, and when we put f double prime x equal to 0, and then I try to simplify it by dividing by 12, I got this as my quadratic equation. This quadratic equation, if we just want to see if there is a solution or no solution, then we just have to find the discriminant. So I found discriminant is positive. Because the second derivative of this quadratic function comes out to be quadratic, and this quadratic function has 2 solutions because discriminant is positive, therefore there will be 2 points of inflection. If a question is asking to actually find those points of inflection, we should go one more step, and we actually find the solution of this quadratic equation, find those x values, and we substitute back in the function to find the corresponding y values. So I think this question is straightforward, so you understand. I didn't actually try to find the point of inflection. I just want to explain if there will be points of inflection or not. Make sense? The second question I got is again from section 3.5, page 64. Question says, this is an open-ended question, means if we try to solve it, we might end up getting a lot of different answers, right? So I'm gonna just go over the approach, and then at the end I'm gonna explain how many different solutions you can get. So the question is asking, there is a function, it has a max point, local max point at x equal to -3. That means f prime -3 will be 0 because there's a turning point. And there's a point of inflection at x equal to 1. That means the second derivative at 1 has to be 0. Remember, it doesn't say how many points of inflection this function had. So I assume the question says there's only one point of inflection and there's only one local max point. Because there's only one point of inflection, that means when we find the second derivative of this function must be a linear function. And first derivative has to be quadratic, and then function has to be a cubic function. So based on the information given to us, I made a conclusion the function has to be a cubic function. because second derivative gives us only one solution at x equal to 1. So because it's a cubic function, so I can make the assumption this is my function ax cubed plus bx squared plus cx plus d, and then I find first derivative, then I find second derivative, then I put in those conditions. The condition says there's a local max point x equal to -3, therefore f prime -3 has to be 0. And because there's a point of inflection at x equal to 1, therefore f double prime f 1 has to be 0. And then if I do substitute x equal to -3 and x equal to 1 here, I got two equations, 27a minus 6b plus c equal to 0. And I got second equation 2b equal to -6a. That means b has to be -3a. Now because b is -3a, what I did, I tried to substitute this value b -3 and 3a in this equation, and I got another equation at the end, which is c equal to -45a. So still we have four variables a, b, c, d, and that's not enough information. That's why there are so many solutions for this question. So I got one equation, b is equal to -3a here, and b is equal to c equal to -45a, and therefore I can make any assumption on the value of a. If I know what's my a value, then I know what's b value, then I know my c value. And then d doesn't depend on any of those. That means I can assume any value for d. Now question is, can we make any value of a, which is actually not correct in this case. So because it's a cubic function, if a is positive, then the graph function will be like this. If a is negative, then function will be like this. If I use a negative value, then my function will be this one. My graph will look like this one. That means at x equal to -3, there will be a min value, not max value, at local min value. So that's why I have to make the assumption that a has to be a positive value, any positive value. I made assumption 2. Therefore my graph will look like, with leading coefficient positive, will go from third quadrant to first quadrant. Then there will be local max at x equal to -3, and then point of inflection will exist at x equal to 1. I can make negative a values. So this is, I think, really clear for everybody to know, because otherwise you can pick any value, but we also have to meet the condition. There will be a local max point x equal to -3, and we can't have the local max at x equal to -3 if I assume a negative value, because point of inflection comes after the local max. So I made one assumption, a is equal to 2, and then I found b, and then I found c. If a is 2, b has to be -6 and c has to be -90, because c is equal to -45a and b is equal to -3a. So this helps me to find the function. Now remember, d is independent, so I can have d equal to 0, 1, 2, 3, 50, 60, 100, whatever you want for the d value. So I made this graph to explain my answer is also correct answer, but this is not the only answer. If you try to substitute a equal to 5, 10, 2, 100, 200, you will get different function, but it will not change the conditions. There will be local max at x equal to -3, and there will be point of inflection at x equal to 1. And to make it more clear, I also included the function for f double prime x. See, f double prime x is 0 at x equal to 1. This proves that there is a point of inflection at x equal to 1, and this is point of inflection, and there's a local max at this point. This is, remember, is one of many solutions. It's not the only solution. So remember, this is an open-ended question. That means everybody in class, everybody will try to do this question different way. It will end up a different solution, but still will still be meeting all the conditions given. All right, so next I'm gonna go over your optimization problems. I have few I received from you, and I need to clarify a few other concepts of curve sketching. So wait for my next video, and hopefully you will do well.